Hey class, I'm going to be modeling for you how the rock cycle works in the 3 types of rocks using Starburst. This is a lab that we would normally do in class, but I'm going to model it for you. Since I'm at home in my kitchen, my tools are a little bit different than what they would be in the science lab, but for this I'm going to break it up into 4 different parts, and for safety I'm going to need to pull my hair back. And whenever I'm dealing with heat, I'm going to be using an oven mitt so that I don't burn myself. Okay, so now that we're ready for part 1, I'm going to be modeling rocks weathering into sediments. So I have starbursts of 4 different colors to represent different types of sediments. So first, I'll cut the starburst candies into strips and then small pieces. So I've started cutting them into strips. It's harder than you think with just scissors. Cutting them into strips, and then now I'm going to cut them into some smaller pieces. So this part is modeling what? It is modeling sediments weathering and breaking down into little pieces, smaller pieces. And this is probably good. Here's all of my different sediments. They're different colors to show different colors of sediments and pieces. Alright, so part 2 is making sedimentary rock. So how sedimentary rocks are made is sediments are weathered and broken down, and then they're compacted together into one rock. So that's why in sedimentary rocks we usually will see different pieces of different things inside of the rock, different colors. You might see some sort of bands or waves. Fossils can be found as well. So how we're going to model making it is we're going to take all of our sediments and we're going to mix and compact them together, squeezing with my hand. So I'm going to take all my sediments, and they're about to be compacted and cemented together to make one rock. So with sedimentary rocks, like we said, the different pieces are compacting and cementing together, and a lot of times there is a little bit of heat. Not very much. It's not like metamorphic rocks where it's extreme heat, but there's slight pressure, slight heat, and the heat from my hand is modeling the slight pressure that's needed to compact and cement these sediments together. Almost there. Okay, so now here is my sedimentary rock. You can see all the different sediments and colors and pieces in it. Okay, so part 3, now my sedimentary rock is going to start turning into a metamorphic rock. So first I'm going to place my sedimentary rock inside of this plastic bag, and I'm going to close it, and I'm going to apply some heat and pressure with my hands. So a little bit of heat from my hands, a little bit of pressure. When it's soft and pliable, I'll be placing these heavy cookbooks. Normally I use textbooks, hopefully these cookbooks will work, on top of the candy in the plastic bag, and to apply more pressure. So I'm going to heat it up a little bit more with my hands. A little more pressure. Okay, so I've now applied more pressure with the books, and you can see it's pretty flat now. It's starting to flatten out, which a lot of metamorphic rocks appear very flat because of this reason. So then I'm going to take it out of this bag and fold it. And then I'm going to put it back in the bag and apply more pressure. Okay, so now we have our metamorphic rock. We applied heat and pressure, and then we folded it and applied more heat and pressure, which is part of the process of making a metamorphic rock. So whenever you see extreme heat and pressure, we're almost always going to be talking about a metamorphic rock because that's the two main things that creates them. So that's why a lot of times, for example, when I folded this rock and applied more pressure, you can see different bands of color. And that's one thing that's used to identify a lot of metamorphic rocks. You'll see different bands from all of the pressure and the folding that was done in creating the rock. Now this obviously isn't a perfect example, but it does help model it to help you understand a little more. And a lot of metamorphic rocks will appear kind of flat looking on the top and bottom as well. So now for part 4, we have our metamorphic rock, and now we're going to be making an igneous rock. So it's now going to be turning into an igneous rock. So safety for this part, normally I would be using a hot plate, but since I am at home, I'm just going to be using a pan. So I'm going to take my rock, and I made a small little boat to place my rock in out of aluminum foil. And I'm going to place my metamorphic rock inside of it. And now I'm going to put my boat with my rock inside of it onto what would be our hot plate, which instead is just a pan. And I'm going to allow it to melt and bubble, just like what happens when igneous rock is being created. Then we're going to take it off and allow it to cool, because it's going to melt down and bubble, and then it's going to cool and harden to create igneous rock. Our metamorphic rock is starting to heat up on the pan, and pretty soon it will start to melt and bubble. So it's really starting to melt and bubble now, which is representing the lava or magma bubbling, and this is why a lot of times igneous rocks may have air bubbles or little air holes inside of them to show where the bubbling that was occurring. It's almost all the way melted down now. Now that it's completely melted and bubbling, I'm going to remove it from the pan to start cooling. Now we're going to start the cooling process. We just did our melting down. Now the rock's going to cool and eventually harden. Okay, so now our rock has almost completely cooled and hardened. It's still pretty warm, so it's not completely done yet, but the parts that are starting to get hard, you can see and kind of hear it's starting to get glassy, almost like Jolly Ranchers, and shiny looking. And that's another thing that occurs in igneous rocks. One way to identify is they're usually glassy or shiny looking. Not always, but a lot of times they are. It's easier to see when you do this experiment yourself. However, you can see here on the camera though that it's dry and getting glassy, shiny, a lot like I said, a Jolly Rancher. But it's going to continue cooling and hardening. It's still a little soft in the middle. Bubbles in them. So a recap of what we did to model the rock cycle. We first broke down our starburst into sediments and little pieces. The pieces of rock weathered, broke down. Then we compacted and cemented those sediments together to create sedimentary rock. And then we took our sedimentary rock and applied heat and pressure, folded it and applied more pressure, and then that created our metamorphic rock. Then our metamorphic rock was melted down into igneous rock, melted down and then cooled. So that's a basic model of the rock cycle, and I hope that this helps, and let me know if y'all have any questions.